In this practical session, we have to learn about the NumPy library. So this is the first lesson based upon a practical of NumPy library. In this session, we have to see about creating an arrays. So basically, that is the very basic things in particular with the NumPy. So how to start to work with the NumPy? So for that, first of all, we have to import the library, and that is the NumPy. So we can also run this code like import numpy, and also for creating as a shortcut we have to use a creating import numpy as np. So that's why whenever we want to work with the numpy library we can also use a shortcut of numpy library. Next things we have to see how to create an array. So basically array will create in two ways. First way, that is you can directly easily create array with the help of the numpy library, and second form to create, that is the first of all you have to create a list and then you can convert list into the arrays. Let's see with the first of all with the list, and then we can see about with the help of the directly creating array. So here my first list, that is you already know how to create a list. So particularly for list we have to use this type of parameter 1 2 3 4 5 and 6. So this is my list number, my list. Okay, so now it's time to create an array. So now I have to provide my array 1 and then is equals to np dot array. So why we are using np dot array? Np is stand for the numpy, and this numpy shortcut, that is the np, that's why we are using np. But why we are using an array? Because here we have to create a array based upon a numpy library. That's why we are using np dot array. Array is the function of the numpy library, that's why we are able to use easily like np dot array. Then we have to provide simply my list, what are the list we already created over here, and then we have to run that part. Now it's time to call our array what we had already created over here, that is the my array 1. Once I can run these things, we are getting an array 1 2 3 4 5 6. So that's how you are able to create an array. But if you want to create array directly like this one, now I will show you how you can able to create directly array. So just a simple, the name is the ARR, and now I will show you how you can create np dot array, and you have to take these brackets. Particular in this bracket you have to take this type of square bracket, and now you can create 1 1 2 and 3 and 4. So that's how you are able to create a simple array directly with the array. Because before I show you how to create an array with the help of the list, but now I will show you how to create array just in terms of direct things. Now let's talk about how we can go with the, if we are creating multiple lists, and based upon a multiple list if you want to create a two-dimensional array, so that things now we can see. I already created my list over here, so I can replace this one as a my list 1, and now again I can run this one, so I'm getting my array 1 over here. And now it's time to create a my list 2. The my list 2 I already taken over here, and this square bracket I have to taken some values like 11 22 33 44 55 and 66. That's how we can create my list 2. Again, if you want you can also use this code as well as. So here for that I have to again provide over here the 1. So here, just a second, I have to copy this code and I have to again paste it over here, and simply I have to replace this one my array 2 in replacement of my list 1 as compared to my list 2, and I have to run this code. And here I have to provide simply my array 2. So the here we are getting both the different arrays. But if you want to make it one list, and in particular that list, if you can combine the my list 1 and my list 2, that is also okay. So let's see how we can apply the same thing over here. So for that I can add one code over here based upon that, and that is based upon a my lists is equals to, here we have to take two lists, my list 1 and then second one is the my list 2. So based upon that I have to call the my list and I have to run this code. So here I'm getting 1 2 3 4 5 6. Also parallelly I'm getting 11 22 33 44 55 and 66. Now in terms of my list 2, here I can only replace the my list So here that will affect over here, and now I'm getting the array in 2 dimensions. So here row and column, both the things are present over here. So that's how you are able to create a single dimensional array as well as multi-dimensional array. Also, if you want to find out some basic things related to your array, you can also find out like shape and data types. So let's see how we can add that part. So that for that we have to use first of all this one, and I have to copy this one, I have to paste it over here, and then we have to take a myArray2 dot shape. So shape was 2 and 6. So what is the meaning of 2? So basically there is 2 rows are there and 6 column are there. 2 is stand for the rows and 6 is column for the 6 is stand for the columns. Also you can find out the data type. You are easily getting an idea if this data type is represented with the integer type of things. So that's why data type, that is the integer 32-bit. Also, with the help of the NumPy library, if you want to create a number of zeros in terms of only particularly in terms of rows, so you are also able to create that one in terms of rows as well as columns. So that's why there is particular one function is there, like np of zeros of what are the particular number of zeros you want. You can type that number over here. If you want 5 zeros, you can take it like this one. Similarly, you can also take it like np of ones of 5. So here you are getting the, sorry, I already take it 4. So here 4 ones you are getting over here in terms of column. So basically again you are getting the floating the data type of this one. So till now what are the myArray2 is there, that data type, that is the integer. But what are the things we are created over here, that data type it should be shown and shown as an floating point. So let's check it out how it will show. So for that I have to given some other name over here, array3 is equals to, and now I have to run this one, and then here I have to provide my array 3 dot d type. If I can run this one, I'm getting float 64. So the meaning of float 64, that is they all are the floating point with the 64-bit. So next things with the basic of NumPy, we have to see about how to create a matrices of the particular dimension like 5 cross 5 or 4 cross 4 with the zeros and ones. So for that we have to simple use np.ones in the particular circle bracket. We have to take on one square bracket, and here we have to provide some dimension, how many rows you want and how many columns you want. So I want to create 5 cross 5, so that's why I have to take 5 and 5. So here same thing I'm getting over here. So similarly based upon np.zeros you are also able to do the same thing. So let's check it out how we can do. np.zeros in particular bracket we have to take on 4 and 3. So I have to change the dimension, and according to dimension here what are the change we are getting over here. And particularly in the creating array, last thing that is based upon a arrange. So how you can arrange the things based upon a array. For that we are simple again use np dot arrange function. So arrange function will provide the particular one type of the number, and throughout number we are getting the output like 0 1 2 3 4, because we are providing the range of 5. That's why you can also apply it similarly as a range, because whenever we can talk about the useful operator, at the same time we discuss about how to apply the range. So same concept we are able to apply it over here. np dot arrange of, you have to provide the starting point, that is a 5, ending point here is a 50, and the step size, that is the 2. So here you are getting all the odd numbers between 5 to 15. So that is the answer. So that's how you can go with the creating arrays. So that can helpful to get the basic idea about the NumPy library. In our next topic, we have to discuss about the using arrays and scalars. In this practical session, we have to see about using arrays and scalars. So first of all, whenever we can work with the NumPy, first thing that is the import NumPy as np, and we have to run this code. So after running this, we have to just recap one or two things what we already learned in the basics of data structure based upon a modulo. So 5 divided by 2, that is a 2.5. So that type of things we are getting based upon a remainder. Also, we seen about like if I have to taken 5 modulo 2, so what is the answer? So answer that is the what. So that type of things is always important things when you can try to run some of the coding things based upon libraries. So let's create first array based upon np.array. So now array1 is equals to np.array, and particularly here I have to select something. Here, if I want to create a two-dimensional series, two-dimensional data in terms of this two-dimensional array, so I have to take a square bracket over here. So particularly, I have to take a two square brackets. The one square bracket will not run. So particularly in the first square bracket, I have to take it 1, 2, and 3, and then I can also take it 4. Okay, so now we have to take another square root. Sorry, square bracket. So and another bracket, we have to provide the 8, 9, then 10 and 11. So this should become an array number 1. If I can provide I have to run this code like array 1. So I'm getting an answer 1, 2, 3, 4, 8, 9, 10, 10, 11 in the two dimension. So that is the very important thing in a two dimension array. Now we have to see about the basic arithmetic operation in terms of array, like array 1 multiplies array 1. So once I can run this code 1, 4, 9, 16, 64, 81, 100 and 121, and so we are getting over here. If we should take array 1 minus array 1, we are getting the answer 0, 0, 0, 0, and then again 0, 0, 0. So almost many more operation we are able to do, like 1 divided by array 1. So here 1 divided by array 1, it means 1 divided by 1, 1 divided by 4, 1 divided by 9, 1 divided by 16. This type of things we are able to do with the arithmetic operation. Also, we are able to do array 1 power 3. So here we are getting all the cubes based upon the array number 1 or the array 1. So now you are getting the idea how to work with the using arrays and scalars with the NumPy library. Next, we have to mention about the functions of arrays and many more things. In this practical session, we have to talk about indexing array. Again, in the NumPy, indexing and slicing it will play an important role. So let's see how we can apply indexing and slicing particular on the array. First thing, that is the import NumPy as NP. So with that, we are starting the things. Now let's create one simple array. So array is equals to np dot array, but as compared to array, now I want to take np dot arrange. So with the help of the arrange function, now I want to create an array in between 0 to 11 numbers. So here my first array was created over here. So in multiple ways you are able to create an array. So in this way you can also able to create an array. So now let's check it out some indexing concept over here. Already after learning about the indexing and slicing, you already get an idea. So indexing based things are always based upon a position. So let's find out the array of 0 position, what things are stand over here. So on 0 position, 0 number will stand because indexing will starting with the 0. So basically, if I have to put down the array of -1, so here I'm getting answer that is the 1, because array should work in positive and negative, forward direction and backward direction. In both direction it should work. Also, we already seen like how to grab the particular information. If I want to access the number between 1 to 6, so that's why I have to write down the 1 to 6. So I'm getting the number in between 1 to 5 over here. 1, 2, 3, 4, and 5. So that's how array indexing should work. But there is one advantage are available in array indexing. You are also able to replace the things that is not easily available with the string and list. But that things you are able to do with the array. So let's see how we can able to do that three things. Array of 0 to 5. So in 0 to 5 we are having 0, 1, 2, 3, 4 numbers are there. Now I want to replace the 0 to 5 numbers with the replacement of 100. And now after running this code, now I want to check the array. So here the 0 to 5, it means 0, 1, 2, 3, 4 numbers are already replaced with the 100 and remaining numbers are look similarly. Let's check it out one more thing and we can see the same thing based upon a slicing. So now I want to create a new array. So array is equals to NP. Okay, let's do not need to create a new array. We can implement the change in similar this array. Okay, so that will looks very complex, and it's also give an idea about the slicing as well. As slice of array is equals to array 5 to 11. Now it looks better. And then again here slice of array, we have to run that code. Slice of not defined. Okay, 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 okay. Yes, now it's perfect. Yes. So we are getting the 5, 6, 7, 8, 9, and 10 numbers. We are just only getting from 5 to 11. Now what are the things we have to do? Among that number, first of all, I have to copy that number. So among of this number 5 to 10, I have to equal that all the number in terms of 99. So for that we have to take semicolon, and here we have to apply 99 when we have to run this code. Now if I can provide the array, so you are getting the difference over here. The 0 to 5 are look like 100, and the remaining number are look like a 99. So that type of things we are able to see based upon the indexing and slicing of array. Also array are having their one main function, that is a copy function. So now let's see how to apply a copy of array. So for that we have to simply take a array that is already array created, and we have to use the copy function over here with the blank bracket, and then the array of copy was already ready over here, array copy, and here we are getting the copy of our previous one array. So after getting idea about the indexing and slicing of array, now let's talk about the how to create two-dimension array. Already whenever we should learn about the list, at the same time we are seeing the one concept, that is a nested list, and particular in that part we are creating many lists, but that list are not looking in terms of the particular matrix, but here we are create one for a proper matrix. So let's create a variable for the matrix with the help of the array. So for that we have to take np.array, in particular in that array we have to take normal bracket, particular in that we have to take all the things based upon a square bracket. But whenever you should try to create a two-dimension table like matrix, so you have to take a 2 times brackets, circle brackets. So that's why it will give in two outer dimension, because whenever you want to work with the 2D, you have to provide two outer dimension. If you want to create 3D, so you have to provide three outer dimension. So particularly in that I want to provide the two outer dimension. That's why. So we have to create first list. Now second list is 20, 25, and 13, and again third list is 35, 40, and 45. So that is the, so we have to check it out everything looks perfect or not. Yes, everything now it's perfect, and we lastly we have to call up matrix, and we have to run that part. So here we are getting an idea: 5, 10, 15, 20, 25, 30, 35, 40, and 45. Also we are able to apply a indexing and slicing concept based upon two dimension of matrix. So let's see how we can see. So if I can provide the matrix of 1, so here I'm getting an answer look like a over here 20, 25, and 30, because 5, 10, and 50, 5, 10, and 50, it will stand for the 0 position. This one will stand for the 0 position. This will stand for the first position, and this will stand for the second position. So now here I'm getting an answer 20, 25, and 30. If I have to take an same thing and provide it over here, and in a second bracket I have to take an again one, so I am the getting an answer that is a 25, because again if we are having this one, so again we have to start it with 0, 1, and 2, so the final answer that is the 25. So that's how matrix should work. Let's find out some more thing like matrix of, again we have to first of all provide the semicolon, and then we have to provide the 2. So here we are getting answer in terms of the 5, 10, and 15, 20, 25, and 30, because it should work in terms of the rows and columns. So whenever you should take this one, so meaning of that they are just only taken the particularly semicolon 2 rows. So that's why they are considered 0 and 1. Okay, so if they are just only considered 0 and 1, that's why we are just only getting this one as a output. But if you've taken just like only first two rows and first two columns, so for that you have to again create one logic for particular that one. For example, if in the answer I just only wants to get 10, 15, 25, and 30, so for that I have to create one logic, and particularly first logic I have to made it for the rows, and second logic I have to made it for the column over here. So when I have to take a semicolon and two, it means I just only wants to take first two first two rows like 5, 10, 15, 20, 25, and 30. Let's check it out with the same thing. So here if I can apply the same thing, I'm getting 5, 10, and 15, 20, 25, and 30. But among that, I just only wants to get 10, 15, 25, and 30. So for that, what I have to do? Again here, I have to apply the 1 and semicolon. So that's why I'm getting 10, 15, 25, and 30, because these 5 and 20 is related to the zero position of column. 10 and 25 will stand on the first position of column, and the 15 and 30 will stand on the second position of column. So that's how this whole thing was working in terms of indexing and slicing of arrays and the matrices. Also, if you want to do some more practices, so you can also create a different type of the with the help of the zeros and ones, you are also able to create many more things based upon this type of the matrices. In this practical session we have to learn about the array transposition, and also we have to see about some different techniques to create in matrices or the array. So for starting, first of all we have to import numpy as np. So here NumPy was already imported over here. Now we are trying to create a new array, but with the different things. Till now we already seen how to create an array based upon a arrange function. So here the arrange function is already taken by me, and particularly in the arrange I have to selected 50 numbers. 0 to 50 numbers I already selected, but particular 0 to 50 numbers I want to reshape, or I want to apply in the particular shape of the 7 cross 7 or the 10 cross 5. So there are particular shape are there. If you should take 7 cross 7, so it means 7 rows and 7 columns of matrix you want to create, and particularly in that matrix you want to use 0 to 50 numbers, but here I want to create the 10 rows and 5 columns of matrix. So that's why here I have to selected 10 cross 5, and I have to run this code. So here you are getting an idea how you can apply the same thing. Also, if you want to make it a 7 cross 7, so you should use like 7 cross 7, and now you should run this code. So here whenever you should take 7 cross 7, so they are given an error, cannot reshape array of size of 15 to 7 cross 7. So for that you have to take on 49, and with the 49 you are getting the correct answer. So that's how you can implement, you can first of all create the array with in terms of the reshape option. Now it's time to apply the array transposition. To apply array transposition, you have to simple write down the array with the transpose t, and then you have to run that code. So automatically with the help of this code, the array will transpose over here. Now if you can check, you can get an idea. Basically when we can apply the transposition, so in a transposition, rows are considered as a column and column should consider as a rows. Let's check it about how to create a dot product with the NumPy. So to create a dot product with the NumPy, you have to use np dot dot, and particularly in that you have to provide the array and array dot transpose, and you have to run this code. So at the same time, you are getting dot product between array transpose and the array. So in last particular session, we can talk about how to create a two-dimensional matrix. Now it's time to show about how to create a three-dimension array. So for that, we have to create a next array based upon array three dimension. And in that array, we have to first of all take an np dot arrange, and based upon np dot arrange, we have to provide some shape. So here I want to just take a 5 as a shape, and based upon that 5, I want to apply also the reshape. And in reshape I want to take it 5 cross 2 matrices. So 5 is the basically we have to take on 5 rows and 2 columns, but as well as here that is the 3 dimension are there, so also we have to decide how many total matrices you want to create. So total I want to create a 5 matrices in 3 dimension. So whenever you are to trying to create a 3 dimension matrix, at the same time you have to provide the 3 arguments. First argument is based upon how many matrix you want to create in third dimension. Second thing is based upon a rows, and third thing based upon a column. And again, once you can complete this one, then we have to call the array 3 dimension. So here we are getting an array cannot reshape array of size into the shape of 5 cross 5 cross 2. So let's check it out. What are the errors we had done? Yes, actually the error is not based upon that error, because whenever we are trying to do this one, we have to provide one more bracket for providing the outer dimension. So that is an error is made by us. So again we are getting an error. I have to check it out. What are the issues? Okay, it is not working or not. We have to check np dot arrange reshape 5 cross 5 cross 2. We have to check it out. What are the things are coming over here? Okay, so let's see. We can change this number because I think I can provide the 50, but here they're just only 5. So we have to run this code. Now it's getting a proper answer. So when we're trying to apply the third dimension, so we have to provide total 50 numbers. So according to the 50 numbers, we are getting the proper result over here. And that's how this thing should working over here. So basically among the 0 number to the 49 number till 49 number, we are getting the final result over here. So based upon that, we are able to create a 3 dimension matrices. Also, if you want to apply the transpose of the 3 dimension, you are also able to do the same thing. So that is depends upon you, like how you want to create the same thing. So for that, what we have to do, let's check it out how to apply the transpose with the third dimension. So for that, you have to take array of 3 dimension dot transpose. You have to take dot transpose, and with particular that you have to take it 1 0, and then you have to take another 2. So according to 1 0 and 2, you are getting the proper things in terms of the array of transposing. So here these all are the brackets will represent the outer dimension. So outer dimension is very important whenever you are working with this type of things. So in the next things, we have to see about the universal array functions. In this session, we have to talk about universal array functions. So basically with the NumPy library or the array function array, what are the universal functions are working as a appropriate. So first of all, we have to import the library, import NumPy as np. And after importing the NumPy library, we have to make it one sample array based upon the np of arrange with the particular number of 11. So here the array is already created over here. So let's talk about the universal array function. So what are the universal functions are available with the array? So first function is based upon the square root. So we have to take an np dot square root sqrt square root, and under the bracket we have to provide the array. So here we are getting an idea like 0 square root, we are getting 1 square root, 2 square root, third 3 square root. So all the square root value we are getting over here. So what are the value here we are getting over here? All the values are coming in terms of the floating of 64-bit. Let's see about how to exponential value we are getting. And here we are getting idea about the exponential function. So with the help of the exponential function, we already provide the things onto the array, and here we are getting the same answer over here. Let's create one more array based upon some random thing, like a is equals to np dot random dot rand n will stand for the random numbers, and random will stand for the random library. And then among that, I want to find out the total 10 random numbers. So here with the help of a, I'm getting the 10 random numbers. Similarly with the b, I want to apply the same thing over here. So that's why we have to write down the the random dot rand n of, again here we have to take on a 10 numbers, and that will stand for the b. So the A is also random numbers of set, and B is also the random number of set. So based upon this random number of set, I want to find out the binary function that is based upon a addition function. So for that, we have to take an np dot add of A and B. So if I can run this code, I'm getting the addition of A and B, and both A and B are the random things are over here. Also we are able to find out the maximum things among that, like np dot maximum of a and b. So here we are getting the maximum thing, but still here I'm getting an error. So the error is due to the, I think the maximum, I think m was the capital according to that one. So we have to check that things like what are the issues in spelling. Okay, so the here error is based upon the maximum, and I just write down the maximum. So yeah, so I'm getting the correct answer over here. So that's how based upon a universal function we are getting the maximum number, as well as we are also able to find out the minimum number over here, like within the A and B. So again the minimum, yes, the same error again done. Yes, so that's why we are getting the same thing for the maximum as well as for the minimum. So the NumPy library, what are the things we had to learn based upon the NumPy library? All the basic or all the important things we already learned based upon that part. And in the next things we have to learn about the array processing, like how the array should process. And basically that topic is looks very based upon some trigonometry type of things are also shown over here, so we can learn on that topic, particular that one. In this practical session, we have to learn about array processing. So array processing is the last practical topic in the particularly Python libraries with the NumPy. After that, we have to learn about the Pandas library. So let's start it with the array processing. First of all, we have to import the library as import NumPy as np. But here, just only NumPy library is not efficient or the enough. We have to import another library, and that is the matplotlib library. So for that, we have to write down the code import matplotlib dot pyplot as plt. So why here matplotlib library should be used? So with the array, what are the array we are getting? If you also want to make it some plot based upon that array, so at the same time we have to use matplotlib library. And also for making some reference, we are also providing one more line based upon the matplotlib, that is the matplotlib inline. Because if you are not providing this matplotlib inline type of course, at the same time at some time you are getting an error based upon the pixel, that's why. So let's create some point for particular that for array processing. So point is equals to, we have to use some np.arrange. You already aware about the np.arrange. We have to take on some point from -5 to +5, like -5 to +5, and we have to provide some step size around 0.01. So based upon this point, we are able to create dx and dy. So here, particularly with the dx and dy, what we have to do, we have to create one mesh grid. It's a one type of the blank chart I want to create. That's why we have to use np dot mesh grid. And if you want to develop this mesh grid at the same time, also the matplotlib should be helpful. So we have to take in points. So both the times we have to take points. I have to take just only point. That's why we didn't use s. So we already created dx and dy. So let's check what is the value of dx and what is the value of dy. So here, based upon the value of dx and dy, we are getting an idea. So all the values are coming in between 5 -5 to +5 with the step size of 0.01. Based upon that, from the trigonometry, you are also able to develop some sine function as well as cos function and tan function. So let's see how to develop sine function. So for that, I have to create a z, and z is equals to, we have to write down in a circle bracket np dot sine of dx, and then we have to provide the plus np dot sine of dy. So that's why np of sine of dx plus np dot sine of dy. So based upon that, we have to find out the z over here. So this is the value of z. So that's how with the help of the NumPy, you are also able to make it some trigonometric things. And now based upon this one, now I want to plot the simple plot based upon this calculation or this value of z. So plot dot im show of z. Whenever you are using the matplotlib library, and based upon this matplotlib library, you want to show some type of the charts or plots, at the same time you have to use plot.im show or the plot.show. It is also available with that part. So if once I can run this course, so then I'm getting this type of visualization. So basically this type of visualization will it just only represent the particular calculation of the z, that is based upon a sine of x and sine of y. So here, particularly array processing, that was completed over here. And in next part, we have to talk about, or we have to see some practical things based upon the pandas library.